But there is a language in Europe that fits nowhere. Surrounded by Romance and Germanic tongues, it stands apart, older, stranger, untranslatable into the family trees that explain everything around it. For centuries, the people who speak it were treated as a relic, a leftover, the last echo of something pre European. The story seemed settled, patient. Then the DNA arrived, and the settled story began to wobble. The Basques, living in the mountains and valleys along the border of Spain and France, Ursher, have long been called Europe's oldest population, the people who were there before the others arrived. It's a romantic idea. It's also, researchers now suggest, are too simple. For decades, the accepted explanation went like this. When farming spread into Europe roughly 7,000 years ago, new populations swept across the continent, irreversible, mixing with or replacing the hunter-gatherers who had lived there since the Ice Age. Almost everywhere, that mixing happened, but in the Basque country, the story went, something different occurred. Isolated by mountains, protected by geography, a small population supposedly stayed put genetically and linguistically untouched. A frozen window into Europe's deep past. It was a tidy narrative. The unique language supported it. The geographic isolation supported it. Even older genetic studies, with their limited sample sizes, seemed to support it. Case closed, or so it seemed, but the data may indicate something else entirely. Sure. And the first sign that something didn't fit came not from a lab, but from the shape of the land itself. If the Basques were truly an untouched Ice Age population, you would expect their DNA to closely resemble the oldest hunter-gatherer skeletons recovered from across Western Europe, the lineages that existed before farming ever arrived. And in some ways, it does. Basque populations carry unusually high levels of ancestry connected to those early hunter-gatherers compared to most of their neighbors. Except the match isn't as clean as the old story required. When researchers began comparing modern Basque genomes to ancient DNA recovered from skeletons across the Iberian Peninsula, something curious emerged. The closest genetic match wasn't to the deep hunter-gatherers of 10,000 years ago. It was to farmers' early agricultural populations who arrived in Iberia around 6,000 years ago, during the period the isolation story claimed the Basques had avoided. And that was not a contradiction, it was a signal. This is where genetics as a tool starts doing something archaeology and linguistics alone cannot. That's ancient DNA genetic material extracted directly from skeletal remains thousands of years old, allows scientists to compare populations not just to each other today, but to the actual people who lived in a region at different points in time. Autosomal DNA inherited from both parents and reflecting overall ancestry. This is a broad picture of population mixing. Y chromosome DNA passed father to son, and mitochondrial DNA passed mother to child. Error can reveal whether male and female lineages tell the same story or different ones. And when scientists applied these tools to the Basque country, the old map of an untouched people began to look less like a snapshot of the deep past and more like a single frozen frame pulled from a much longer film. If you'd like to know how that single frame turned out to be misleading and what the genome found underneath it, that's really where this story begins. If stories like this interest you, subscribe, because there is far more hidden in the human past than most of us realize. The first major reassessment came when researchers compared Basque genomes not just to ancient hunter-gatherers, but to the broader wave of early farmers who spread across Europe from Anatolia, or in what is now Turkey, starting around 8,000 years ago. These farmers carried distinct genetic signatures, different from the hunter gatherers who came before them. Across most of Europe, the two groups mixed extensively over thousands of years. The expectation under the old model, Bayer, was that Basques should show minimal farmer ancestry, a population that had largely sat out that mixing event. Instead, the data showed something closer to the opposite. Basque genomes carry a substantial farmer-related component in proportions not wildly different from some of their Iberian neighbors. The story did not collapse, it widened. If the Basques weren't simply an unmixed hunter-gatherer population that farming had passed by, then what were they? Three explanatory frameworks began to take shape, and for a while, none of them could be ruled out. The first possibility, the Basque country, experienced the same farming migration as the rest of Iberia, but afterward, for reasons tied to geography, social structure, or chance, the population became unusually isolated. Limited contact with later migrations into the peninsula meant that, over the following millennia, the Basque gene pool simply stopped accumulating new ancestry streams that arrived elsewhere, not an absence of mixing in the deep past, but a kind of genetic time capsule sealed shut afterward. The second possibility, a founder effect, a relatively small founding population established sometime after the initial farming migration, expanded in relative isolation. Genetic drift, the random fluctuation of gene frequencies in small populations, could have amplified certain ancient hunter-gatherer signals while diluting others, creating a genetic profile that looks distinctive today without requiring the population to have avoided mixing altogether. The third possibility was the most unsettling for the old narrative, that the unique Basque language and the unique Basque genetics aren't actually telling the same story at all. Language can spread, persist, or vanish for reasons that have little to do with who is having children, with whom a population could undergo substantial genetic mixing while a minority language survives, or a distinct genetic profile could persist while the language eventually shifts. Now, the two threads, linguistic and genetic, may have been running on separate tracks for thousands of years, only appearing to confirm each other by coincidence. Researchers remained cautious about choosing between these frameworks. Each fit part of the evidence, none fit all of it. The landmark moment came with the analysis of ancient genomes recovered from sites across northern Iberia, including burials associated with early farming communities in the region that would later become the Basque country. And this wasn't a comparison between modern populations and distant outside groups. It was a direct genetic line sampled across thousands of years, from the people who lived in that specific landscape during the agricultural transition through to the people living there today. What this larger time depth comparison revealed was striking. The genetic continuity between the early farming period populations of the region and modern Basques was remarkably higher in some analyses than for almost any other population in Western Europe. While most of Iberia experienced wave after wave of later genetic input Bronze Age migrations, bringing new ancestry from the steppes of Eastern Europe, Iron Age movements, Roman-era population shifts, the Basque country showed comparatively muted versions of these later signals. So the isolation wasn't ancient. It was relatively recent and remarkably persistent, not the population researchers expected to be the outlier, not for the reasons they expected either. The story wasn't that the Basques avoided the great farming transition that reshaped Neolithic Europe they were part of it. The surprise was that afterward, during the very migrations that to genetically reshaped almost everyone else on the continent, including the Bronze Age steppe ancestry expansion that left a genetic signature in the majority of modern Europeans, something in the Basque country's geography, a social organization, or sheer demographic momentum allowed that later wave to wash around them rather than through them. The genome was not erasing the old story, miracles. It was relocating it, moving the moment of divergence thousands of years later than anyone had assumed, and changing its meaning entirely. This matters far beyond one mountainous corner of Europe. Herschel. The old model of European prehistory often imagined population history as a series of clean replacements. One group arrives, the previous group vanishes or is absorbed. A new layer forms, and so on. Like sediment, the Basque case suggests something messier and more human, that isolation isn't always ancient. Errors, that linguistic uniqueness and genetic uniqueness can have completely different timelines. Gallagher, and that the deepest layers of a population's history aren't always the ones that explain what makes them distinct today. Identity, in other words, isn't a single inherited package. It's something accumulated, and sometimes what looks oldest is actually a record of what happened more recently, layered on top of something older that everyone else also shares. Picture the landscape where this story is written into the land itself. Pillars. The Pyrenees rise sharply along the border between Spain and France, not the gentle rolling hills of much of Western Europe, but steep limestone ridges, deep green valleys, fog that settle into the lowlands and burns off slowly by mid-morning. Sheep paths cut along slopes that have been grazed for thousands of years. Manaras. Stone farmhouses, some centuries old, sit isolated on hillsides, often a considerable walk from the nearest neighbor. Rivers cut through narrow gorges before opening into wider valleys near the coast. Colorful, where the Atlantic brings in cool, wet weather that keeps the hills a deep, almost impossible green for most of the year. It's a landscape that doesn't force people through it, it offers detours. Hidden valleys, places where a community could exist for generations with only occasional contact with the wider world, not cut off entirely, or just slightly out of the way of the main currents. Enough, perhaps, for a population's genetic profile to keep moving along its own trajectory, while the rest of a continent's gene pool was being reshuffled by migrations sweeping in from the east. And when you stand in one of those valleys, what's striking isn't a sense of having reached somewhere frozen in time. It's the opposite, a sense that time moved here too. Spaniards, just along a slightly different path, occasionally diverging from the roads everyone else was traveling, then converging again. Builder. So what does this mean for the old idea of the Basques as Europe's last untouched people? The truth the genome tells is both less dramatic and more interesting. The Basques are not a sealed time capsule from the Ice Age. They are, like nearly everyone in Europe, the product of multiple ancient migrations, hunter-gatherers, early farmers, and at least some later movements, even if attenuated. What sets them apart isn't an absence of history. It's a different rhythm to it, a population that absorbed the deep transformations of the Neolithic just as fully as their neighbors, and then for reasons researchers are still working to fully understand, experienced the later upheavals of Bronze Age and Iron Age Europe more lightly than almost anyone else on the continent. And the mystery hasn't disappeared. If anything, it has deepened. Why this particular region and not others nearby? Was it purely geographic, or did social structures, marriage patterns, Settlement organization, land inheritance play a role in keeping the gene pool more self-contained for thousands of years after the moment of divergence? XHers. Researchers continue to investigate, and the picture continues to sharpen, but it remains incomplete. What the science does make clear is this: Besherer. The old story made the Basques smaller than they actually are, a footnote, a leftover, a population defined by what didn't happen to them. The emerging picture makes them larger, duller, not a people who escaped history, but a people whose history took a different shape than their neighbors, for reasons still being uncovered. That written into genomes that have been quietly carrying that divergence for thousands of years, waiting for the tools to read it. The map of Europe's deep past is still being redrawn. Every population carries pieces of that map inside their cells, even when the surface story, the language, the legend, the textbook explanation points somewhere else entirely. The Basques were never simply Europe's oldest unchanged people. They were something more complicated, a population whose ancient layers are shared with their neighbors, but whose more recent history quietly diverged, leaving behind a genetic signature that took modern science thousands of years to finally notice. If you found this as fascinating as I did, let me know in the comments which population's hidden history you'd like to see uncovered next.